So what is so fundamental here, and to make this very black and white, right now science says that space and time are these whole hard, cold external objects. They're just this invisible matrix out there with no properties whatsoever, and it just self-exists. And of course, first of all, how can these things that you can't feel, touch, or whatever just be out there? So that's a little crazy on itself. So think about it. If you wave your hand through the air and you take everything away, what's left? Of course, the answer is nothing. And the same thing applies for time. You can't put it in a bottle like milk. Space and time are tools of our understanding. So again, the light coming off here bouncing on me, right now, as you look at that, that's happening in your head. You're creating that space. That's not moving through something out there. That's a construct. It's just like when you dream. When you dream, your eyes can be closed, but you can be on the beach with the bright sun, and it can be just as indistinguishable as here and now. So again, your mind has the capacity to put this together, and that is what's going on. And I think we trip up because it's not just black and white. You know, it's easy to say everything is just out there. The problem is it's when you start thinking about it, think about it. If you think of all of eternity, all of time, if there was a time that went on forever, and you put every day and hour and stack them on top of one another like chairs, and put yourself on the top of it, what is the probability that you would right now be sitting on top of all infinity? The good luck just talking to me. The probability of being on top of infinity is 0. That's just crazy. Just a 1 in a gazillion chance that you just happen to be here, good luck, right now, alive in the present. It's just silly. The concepts of space and time as these external matrices, it's just crazy. Immanuel Kant figured that out 200 years ago, even without all of these new sophisticated experiments. The other thing to consider is the universe itself. I mean, it has all of these parameters as though it were fine-tuned exactly like life. Some are calling it the Goldilocks universe because it's not to this or to that. So, for instance, if the Big Bang had exploded 1/1,000,000th more powerful, everything would have rushed out too fast for there to be stars or galaxies. And then there would, of course, be no us. Or if the gravitational constant or the gravitational force was a hair less, the stars wouldn't ignite. There'd be no sun. We wouldn't be here. Same thing for the strong nuclear force, just 2% different, and all you would have is plain vanilla hydrogen. There wouldn't be any carbon or anything for us to be here. And it goes on, hundreds of parameters like this. They could have any characteristic or any number at all, randomly, but they don't. They have exactly, every single one, exactly what it would be for life to exist. To say that that's just a huge accident and we're just lucky, you know, it's just totally, completely absurd. The reason is the obvious reason. If life creates the universe, obviously it can be no other way. The universe is simply the spatial temporal logic of the animal observer. And so, but then that creates other contradictions to things that people thinking in the old paradigm. So, for instance, time. You know, we think of it like this arrow. You know, it just ticks along and that's it, and you can't change it. But we've been doing new experiments that show that that isn't the case. 2 years ago, just a couple years ago, in the very prestigious journal Science, there was an experiment that scientists carried out where they sent particles, little photons, particles of light, into this apparatus. And when it went through to a fork, it had to decide what it was going to do, whether it was going to be a wave or a particle. And then later on, after it passed that fork, there was another fork. And the experimenter could then decide what to do, whether to flip an electronic switch on or off. And when he flipped that switch, then, now in the present, he actually changed what that particle did in the past. So how can what that experimenter do right now in the present actually change something that happened in the past? And there are other experiments, you know, where you can show actually the reverse, that if you have these entangled particles, that if one hits a detector, it has to do something, but actually it can actually will know in advance what you do in the future, whether you put a scrambler in its partner that's had the path stretched out. So again, the thing is we live in that same world. And that's not the world currently described in the existing paradigm. Space and time as these hard objects just doesn't match up with the facts or the experiments. Now, scientists try to get out of it, and they say, oh, there's two worlds. There's the small micro world where the weird phenomena, you know, quantum mechanics occurs, and another whole set of rules for us in the bigger universe. Well, first of all, That's crazy. It has no basis of reason. But more importantly, it's being challenged in the laboratory. So, for instance, just last year in Nature, another very prestigious journal, they did an experiment with entangled particles, these giant molecules, where they actually showed that when they separated them, they acted as if there was no space or time between them. There are molecules called buckyballs, these huge carbon-60 molecules that they actually show, they're clearly in the macroscopic world, show that they follow the same quantum principles. And even a few years back, there were these crystals that they actually showed had entanglement ridges that were half an inch. So where is this division where the laws of physics are one way here and then they change here? Well, we know they're not between here and there. So are they between here and there? The laws of physics change. It's crazy. What we need to do is readjust our way of thinking, which is what science is supposed to do. It's supposed to look at the experiments, not sweep them under the rugs, and it's supposed to make internal consistency, logic of them, so that one theory doesn't contradict the other, like quantum theory contradicts relativity theory. And again, that contradiction, there is absolutely no reason for it. It's obvious why space and time are relative to the observer. We carry them around very much like turtles carry their shells around. And it's obvious what's going on in the micro world about the particles. We have basically what they call waves of probability, which we know from previous experiments aren't material. They're just statistical predictions of where a particle would be. And so until the mind lays that scaffolding down, it can't be either here nor there. Which, again, all of this comes together, and that is what biocentrism tries to do.